Here's another long, bad film about making from Person Make Object. Hey, I'm Kevin from Person Make Object. 2 years ago today, I made the first of these replaceable blade marking knives. I had been wanting a marking knife, so I watched Katz Moses' video on his favorite marking knife, and he pointed out Matt Esley's marking knife design. So I went to Matt's webpage and looked for marking knives, and there were none for sale. I went back a week later, none for sale. For a couple of months, Matt had no marking knives for sale. Matt inspires others to make, so I decided to look at how he made them and make one myself. The first one I made really crudely with pretty simple basic tools. I've since made about 400 and invested a little bit in more precise tooling. But I thought today, on the 2-year anniversary, it would be interesting to go back to really simple tools and see if we can help you use simple tools to make the hardware to make your own knife. You'll need a lathe, some basic lathe tools, a hacksaw, drills, taps, drill bits, files, and maybe just a few other things. You'll also need some 9mm brass rod. I get this from McMaster-Carr. You might be able to get it from Amazon, but it may not be a readily machinable alloy. So be forewarned, ideally it should be 360 brass. And you also need some brass, copper, or other metal tubing. I use 9mm inside diameter, 11mm outside diameter. And the tube and rod slide perfectly together to make the body and the ferrule. Let's get some tools and get this done. So this blade holder hardware is pretty simple. It's a piece of 9mm brass rod that has a slot cut down the center, a hole drilled and tapped, and a tang machined or cut down to length. Then it consists of a ferrule that has a 9mm inside diameter, 11mm outside diameter that slides over the ferrule to make your whole blade holder. You can also use larger diameter tubing or hexagonal rod if you're so inclined. To keep this simple, we're going to use the tube because there's much less machining to be done. This is 40 millimeters long, so I am just going to take a rule and mark out 40 millimeters plus a little bit. The ferrule is 20 millimeters. And just lop these off with a hacksaw. You could potentially use a tube cutter. If you had one of those little Harbor Freight miter saws, that's what I used until I found a better alternative. Here we go, step 1, done. So now we're going to use a wood lathe. In my case, it's a Rikon MIDI lathe, but any woodworking lathe should work. And we're going to clean up the ends of the 9mm by 40mm rod. We're going to cut this shoulder down to about 3/16 of an inch diameter, and we're going to cut those little grooves to create a tang so that when this gets glued into the hole in the handle, it doesn't come out. Work holding is going to depend upon what you have for your lathe. My lathe chuck doesn't get small enough to grip the 9mm rod, so that's out. I could use this other 4-jaw chuck, but I don't like these winging jaws flying about close to my fingers, so I am going to introduce a Morse taper. This is a number 2 Morse taper by ER25 collet adapter. You can get these, the holder, from Amazon for 15 or 20 bucks for an import version of it, and you can get individual collets for about 10 or a whole wide set of collets for like 25 or 30 bucks. It's really a great work holding device for a wood lathe if you're ever going to get into doing things like this. Since we are relying upon the Morse taper to hold that in place, we are going to give it a good solid whack to get it seated in the taper. There we go. And first up, we are just going to face the ends of this, and I am just simply going to use a mill bastard file. You hold that roughly square. It's not going to be critically important that the end of this thing is perfectly square. You just want it to be relatively smooth. Like so. Flip it around, and before I put this in, I am going to mark where I'm going to cut that shoulder to, which is going to be 18 millimeters from the end I just made smooth. This isn't going to be super hypercritical because we're kind of making this one to fit, but plus or minus 18 millimeters is the part that you want to remain 9 millimeters when that shoulder is cut. And I can bury that fairly far in the chuck. Voila, and face this end. Now to cut this brass shoulder, I have a couple of options for you. The first one is a radius diamond tip carbide insert tool. The radius is fairly important. If you have a negative rake one, that's super awesome. The other alternative is to just start with a high-speed steel tool. This was just a square scraper, an old Marple square scraper that I had on hand. And I have ground this to a negative rake angle. You can see I've just put a very slight grind on the tip that's probably 10 degrees or so, and that creates a negative cutting rake, which is exactly what you want brass. So let's try to cut this shoulder with this high-speed steel tool that I ground. If you have a negative rake tool, set the tool rest so that the tip of the tool is right at the center line of the workpiece. If you're using a carbide insert tool or any other tool that isn't a negative rake, set the tool rest so that the back of the tool is higher than the front of the tool, creating a negative rake of the cutting tool. It will take longer to cut this down to 3/16 of an inch than it would if you're cutting wood for obvious reasons. But I am, quite frankly, quite surprised how well this tool works. I'm obviously getting a fair amount of chatter here. This is really just a function of the lack of a really rigid setup, and it's just vibration happening. You might be able to reduce it a bit by changing the speed of your lathe. Doesn't hurt to try. Once you think you're getting close to 3/16 of an inch, I like to use a metal drill gauge pretty frequently, and that is just over 13/64, so I had to take off a little bit more than a 64th off of the whole thing, which means I only need to take a 1/28 off of each side. So I actually think at this point I am going to switch back to the file to create a flatter, smoother surface here, and to get a square corner back to that red shoulder line. Now that's nice and smooth and flat and square, and let's see if it's 3/16. It's 3/16 right on the button. I am ready to cut those grooves for the Tang, and I'm just going to take one that I have cut to lay these out. This is not at all critical, since this is all going to be buried inside the handle. You just don't want them so big, or especially so deep, that they are a structural problem for the integrity of the piece. There's one. Basically, you're just making a groove for the epoxy to fill into and keep it from pulling out of the handle when you turn it. Okay, that ought to do it. Put a little chamfer on the end to make some room for epoxy. And there we have, oof, that collet was tight. We've got a blade body ready for a slot cut in it and a drilled and tapped hole. So one last thing to do on the lathe before we cut the slot and drill the holes is to face this ferrule to length. We're shooting for 20 millimeters. It's not super critical. If it's a little bit long, we can just adjust the length of the tenon later on when we make the handle. That hole is centered if it's right on 10 millimeters or 20 millimeters. So I've changed my collet to 11 millimeters. I can clamp that on there, and once again I just hit that with a file to square it up, put a slight radius on the corner. Where is that rattle coming from? There it is. Switch it and do the other side. So that's cleaned up. Take the handy dandy deburring tool. If you've not seen these before, super awesome, super useful for all sorts of things. There's our ferrule. There's that body we cut earlier. We're ready to slot. So if you're really careful and really good with the saw, you could probably freehand cut this slot and drill that hole in the right place. But to try to assure some better results and maybe make it easier to make multiples, we're going to make a simple little guide block, and we're going to use the blade holder that we've made and the geometry of the Swann-Morton blade to inform that workpiece. I'm going to lay this out and then I'll talk about it. Okay, so what I have done here is just made some intersecting lines on this chunk of wood, which is roughly 2 inches tall and 1.5 inches or so in a cube. Made intersecting lines on the top and 3 of the sides. We're going to drill a 9mm, or if you roll fractional, 23/64 diameter hole, which is a clearance for a 9mm, down to a base point. That's going to hold this workpiece, and then we're going to drill a 3/16 inch hole for the tang. So this thing's just going to drop into this guide block. Then we're going to cut a slot to a point which is some distance above the baseline. That's going to be really established by a Swann-Morton blade. The geometry isn't super critical, as long as probably the hole in the blade is still buried in the blade holder. And then from the baseline that we're going to saw to, we go up another distance as informed by the Swann-Morton blade to where the hole gets drilled for that center point, or for that drill. So center punch these. That's going to be the drill hole for the tap drill. That's going to be the drill hole for the blade body. And we're going to saw a slot almost down to this baseline. Establishing that depth is actually what I'm going to do at the very last point. I'm going to saw most of the way down to it, and then after we get the hole drilled and we can discern what's going on between the blade and the hole and the slot, we'll adjust the depth of it for a tight fit. Another tool I really cannot recommend enough is a good small drill press vise. Since it has square sides and square jaws, it's very easy to hold stuff in and rotate the vise to clamp pieces perpendicular to the table. So I'm using a brad point 23/64 drill bit. This will give me just enough clearance for that 9mm blade body, and I'm setting my depth stop to that line that I made that represents the bottom of the blade body in this fixture. And I'm going to switch to a 3/16 for the bottom of the blade holder, the tang to go through. And since that was a brad point, I'm hoping it should center it on the tip of the brad point. Last hole at 90 degrees to those two is the one for the tap drill, which I'm going to drill only down to the center point of the block, so I know which side to drill the tap hole on. So there is the drill, and now I just need to cut kind of a pilot slot for the hacksaw. We'll be ready to make our part. So to cut this guide slot, rather than going straight to the hacksaw and cutting through wood, I'm going to use the thinnest kerf saw I have on hand, which just happens to be this Veritas Gent saw. And I'm going to try to manage to split that line. So if I've got this line centered, I am ready to drop a blade holder a bit in here and cut the slot with a hacksaw. So obviously the width of this slot is important. You want it to hold the Swann-Morton blade firmly so it doesn't wobble around, but we want it to slide in and out easily. The thickness of that slot is the width of the blade, which is 0.024, 0.025, which is what, 0.63 millimeters. A standard hacksaw blade is a little bit wider than that. I have hacksaw blades, and I didn't need to wander around to try to find something thinner. So what I did the first time I made it is I grabbed a standard hacksaw blade, and I took a sharpening stone. This is just an axe sharpening stone, and I basically ground the set off of the teeth. I did that a few times and took some scrap brass material and cut a slot. Obviously, the saw doesn't cut quite as effectively as it did since I have taken the set off of the teeth, but do that a few times and you can make an 032 hacksaw blade into an 025 hacksaw blade. Now that we have the saw cutting the right size kerf, we can put the guide block in a vise, put a workpiece into that block, make sure it's seated all the way down, and cut the slot. I'm not going to cut all the way down to the base line. I'm going to go maybe a 1/16 or a millimeter shy, and I can adjust that after we drill the hole and can discern the relationship between the hole and the slot with the blade in it. Nice thing about making a guide block instead of just drilling your workpiece is if you screw up when you cut the guide block with your wood saw, you can adjust it accordingly. There's a slot. Now we just have to drill the hole. So the set screw can be either a 1032 or an M5. They're like microns away from being the exact same size. Put the blade holder in the jig. I made this little L-shaped piece of sheet metal to both push it down and seat it all the way, and also to align the slot to make this hole that we're drilling perpendicular. I'm going to set the depth of my drill press to right at that slot depth. Hole. And there we have it. Blade holder ready for tapping and alignment with the blade. So I am back to drill press vise in my wood vise. If you can find a drill press vise that has the V grooves in the jaws, that's even more handy. You'll need a bottoming tap. This bottoming tap I've modified slightly and also put in my plumbing tee as a permanent handle for it. Makes it super easy to find. Give that a little bit of cutting wax. This little plumbing tee is, I find it gives me a little better feedback than a normal tap wrench without the sliding handle, and it fits in my thumb real nice. Keep an eye on the bottom of that slot and be sure that you don't go so far as to open that slot up. There, I'm through. Now if we just deburr this a little, just a 150 grit sandpaper, and I can probably do that on the inside of the slot as well. Now we can determine that a blade goes in, slides to the bottom, and when we look closely, we're going to observe where the hole in the blade and the hole in the blade holder end up. And that's where, if I need to adjust that slightly so that when I put the set screw in, it pushes the blade downwards against the bottom of the blade holder, that's why I didn't cut that slot all the way down when I cut it in the first place. Alright, I have grabbed the set screw and one other thing. This is just a little scraper tool that I made using a Swann-Morton blade. So I just ground it down and put a burr on it. And it works great for scraping the inside of these slots and adjusting a little bit, getting rid of the burr at the bottom of that tapped hole so that the blade slides right in. And with the camera angle change, you should be able to see the holes line up, and the hole in the blade being a little bit shy of the hole in the hardware, so that when I put the set screw in, that 45-degree point at the end of the set screw hits the inside of the blade and pushes it downward into the blade holder, and it's super solid and super firm. Never ever going to come out without loosening that screw. Now we can line up the ferrule, and I'm just going to clamp this in the blade. I could probably think of some fancy way to use another jig to make this one too, but I'm about done on this 2-year anniversary project. So I'm just going to transfer the line from the center of that line. We're going to hit that with a center punch. Oh look, another essential, awesome tool, automatic center punch. Also works for getting into or out of car windows in an emergency. There you go. Drill that with a clearance hole for a 1032 or an M5. We'll do that and put it together. Okay, we are getting super close to having this wrapped up. I have cheated a little bit and put a center hole in that ferrule to drill the hole. Just wanted to mention, I keep talking about drill numbers. This is the number 11, which is a clearance hole for a 1032. Another super handy thing, I've already mentioned the drill index or the drill gauge. This also has tap drills and numbers on it. I also use the one on the inside of my number drill set. Everybody should have a set of number drills, man. If you don't, get one! Alright, so this hole is ready to go. Ordinarily grab a countersink and put a chamfer on that hole, but I'm going to cheat a little bit and just use the deburring tool again. I'm going to use my scraper tool to take the burr off the inside of that hole I just made. And now we should be able to assemble the whole hardware bit. Oops, lost my set screw. You cannot imagine how many set screws I have lost in this shop. That is lined up. Blade goes into the holder. Set screw holes are in place. Congratulations! You've made it to the end of the 2nd year anniversary of me making these knives. There's another YouTube video of making the handles. Put your two together. Wham bam, you've got yourself a knife. You can make your own instead of buying one from me, but you can still buy one from me. Thanks a lot. I hope you enjoyed this. Keep in touch. Drop me any notes. I'm happy to answer any questions that you have. Otherwise, be safe, be well, make on. Thanks for watching. If you like what I'm doing, follows, shares, comments, and likes are always awesome. If you'd like more information or to get a knife, check out personmakeobject.com. Remember, if it's worth making well.